All right, question number one. Um, so let's talk about this question. All right, it says the diagram above, not drawn to scale, um, shows a pole that says TE, but it should have been TF. So TE here should have been TF. So TF is 12 meters high, standing on level ground. It says the points A, F, and B lie on the same horizontal plane. So F, A, and B, F being the foot of the pole, along with A and B lie on the same, lie in the same horizontal plane. We're told that AB is 4.2 meters. We're told that angle BTF is 28 degrees. Angle ATF is equal to 50 degrees. Angles BTF and TFA are right angles. So in a sense, they're telling us things that we can largely see for ourselves. All right, so there was no additional information that we needed to put in. We can see all the information. Everything that they said is actually in the diagram. We didn't have to put in any of the information. We're asked to A, calculate I, the length of FB. All right, so let me draw the triangle that I'm going to use to calculate the length of FB. All right, so I'm going to use the triangle to the left. So it is drawn in a three-dimensional space. I'm sort of like going to represent it as on a two-dimensional surface or as a two-dimensional triangle. So this is F, this is B, this is T. The angle here is 28 degrees, all right? And we're asked to find FE, I'm going to call it X. We're also asked to find FA, so I'm going to draw that triangle as well. All right, so we have F, we have T, the angle here is 50 degrees. All right, this is 12 meters. All right, this angle here is 90 degrees. So we just represented the two triangles on a two-dimensional surface. So let's get to FB. FB over here to the left. Let's change the color ink to red. We're told that this is 12 meters. Down here is opposite. The 12 meters is adjacent. Now the trig ratio, why trig ratio? Because the tools which are used to solve a right angle triangle are Pythagoras theorem and the trig ratio. So the trig ratio that includes opposite and adjacent is tan. So I'm going to say tan. So this is I'm going to say tan is equal to opposite over adjacent. Then I'm going to say the tangent of 28 degrees is equal to opposite is equal to opposite x over adjacent 12. If I have one fraction is equal to one fraction, I'm going to cross multiply. So we can go back up again and see this is opposite x and adjacent 12. If I have one fraction is equal to one fraction, I'm going to cross multiply. 1 times x is equal to 12 times the tangent of 28 degrees. So x, which is FB, is equal to 12 the tangent of 28 degrees. If you put that in a calculator, you're going to get 6.38 meters to 3 significant figure. All right, so the next thing we're asked to find from the same AI, we're asked to find FP, FA. So A is here. I'm going to call it FAY. All right. 12 is opposite to the 50 degrees, and Y is adjacent to the 50 degrees. We already show or we already state that the ratio that includes opposite and adjacent is tan. So I'm going to start out by saying the tangent of 50 degrees is equal to opposite 12 over adjacent Y. If I have one fraction is equal to one fraction, I'll cross multiply. So this is Y times the tangent of 50. All right, just double checking. Yes, it's 50 degrees. Is equal to 1 times 12, which is 12. Next, I'm going to divide both sides by the tangent of 50 degrees. And so Y is equal to 12 divided by the tangent of 50 degrees. So Y which is FA, is equal to 12 divided by the tangent of 50 degrees, and you get 10.1 meters. So Y, which is FA, is 10.1 meters. So we just completed AI. Now we need to look at AII. In AII, we're asked to calculate the size of angle AFB. So let's identify angle AFB. We're asked to calculate the size of angle AFB. So that's this angle here that asking us to calculate. And AFB is part of the triangle on the ground. Let us call this angle theta. So the first thing I'm going to do is I'm going to draw the triangle that is associated with this. All right. So the triangle looks something like this. All right. That is FA. All right. Then let's put in B. This is B. And AB was 4.2 meters. We just calculated FA to be 10.1 meters. We calculated FB to be 6.38 meters. And we're asked to find this angle here. We're asked to find that angle there. And this is angle AFB. All right. Now, to find that angle, I'm going to have to use cosine rule. Now, if you're given three sides of a triangle, we call the angle theta. If you're given three sides of a triangle and you're asked to find three sides of a non-right angle triangle, and you're asked to find one angle, that is a condition for applying the cosine rule. Let's change the ink. All right, now the cosine rule says A squared is equal to B squared plus C squared minus 2BC cosine A. All right, now if you're a non-right angle triangle, you're given all three sides and you want to find one angle, the angle that you want to find is going to be big A. The side opposite to big A is the side little a, and B and C would be the other two sides. So if we put in our values, we're going to get 4.2 squared would be equal to 6.38 squared plus 10.1 squared minus 2 times 6.38 times 10.1 times the cosine of theta, which is the angle that we want to find. So don't let the numbers scare you. Whenever you have to work with decimals, it can, the numbers can look a lot, but don't let it scare you. 4.2 squared, 4.2 squared, and just simply use a calculator, is 17.64, and this is equal to 40.7044 plus 102.01 minus 2 times 6.38 times 10.1, which is 128.876, the cosine of the angle theta. All right, so this becomes 17.64, which is equal to 142.7144 minus 128.876, the cosine of the angle theta. All right, so let's turn the page to complete the question. So now we're going to have let's bring over the 128.876 cosine theta. So we have 128.876 cosine theta. It was negative and it comes over and becomes positive, is equal to 142.7144 minus 17.64. So positive 17.64 comes over and becomes negative. So we're going to end up with 128.876 cosine theta would be equal to 125.0744. Divide both sides by 128.876. All right, and we're going to get the cosine of theta is equal to 125.0744 divided by 128.876. Now, if I wanted to, I could have worked this out, work it out and write the answer to 3 decimal places, or I could keep it and say that theta, which is angle AFB, is equal to cosine inverse 125.0744 divided by 128.876. And then this angle would be equal to, so all I have to do is just put this in a calculator, and you go shift cos, open bracket, 125.0744 divided by 128.876, close bracket, and we get this angle is 14.0 degrees to 3 significant figure. 14.0 degrees to 3 significant figure. All right, so what we've done so far is we have done I and II. All right, because I don't want the videos to be too long, I'm going to break. I'm going to stop the video now. When we come back, we'll do the last 2 points of the last 2 pieces of the question.